Welcome. We'll get started in just a minute. We're letting everyone filter into the room right now. So give us just a minute and we'll get started. Hello and welcome to another Webinars from Anywhere. I'm Silas Robertson. I'll be your host today, and joining me will be Bart Piela, and he's a Cognex Vidi deep learning specialist at Cognex, technical product specialist, I guess. And previously to that, he was an applications engineer. And what they're going to be covering is a product called Vidi from Cognex. It's specifically the Insight D900 with deep learning. Joining him today is Mike Graham. He's our regional vision and sales engineer. He's got a decade of field vision experience and a personal friend of ours. So we really love working with Mike. He's going to be doing some live demonstration at the end. This product and solution, I think, is really going to be revolutionary for factory automation and some of the applications that for years we haven't been able to solve. So I know personally I've sent out some invitations to people that I know. I wouldn't bug you if I didn't think this was a good one to see. A little bit of detail on the presentation today. We do have an area where you can ask questions in your user interface. Go ahead and ask those questions. I'll be monitoring those in the background, answering those that I can. And if I think it's great for the group, I'll bring those to Bart and Mike to answer at the end. We will have a Q&A at the end for everyone. Again, join us again for more of these webinars from anywhere. We're covering robotics, motion, IoT, and even we'll probably do some more of this new vision technology in the future. With that, I'm going to turn it over to Bart, and he can get us started.
All right, great. Hi, everybody. This is Bart. Can you hear me?
All good, Bart. You're
awesome.
Live.
Great. I'll go ahead and get started. So, like Silas mentioned, I'll be introducing this really new and exciting merging of two worlds, which is the deep learning world with our Vidi product and the Insight world, which is kind of our bread and butter yellow smart camera. And those worlds are coming together with a brand new product we're calling the Insight D900. And this is going to open up a whole new world for us in terms of what's possible in the vision industry and what kind of applications we can tackle and how we think about solving challenging applications. So with that, my presentation here will cover a bit about how to think about deep learning, how to think about the product, a little bit of introduction to kind of how the product works and how the tools work. And then we'll go into a demonstration where Mike will do a live demo to show you kind of how the product gets set up, how the training happens, and solve an application kind of right in front of you. And we'll have plenty of opportunities for questions, and hope everyone's engaged and as excited as I am about this new product. So let's see. Okay, so getting into the basics here, this is what the D900 looks like. So if you know our Insight family of cameras, smart cameras, this will look very familiar. On the outside, it looks like our higher end, high resolution cameras, and it is. So we have it spec'd with 5 megapixel or a 2.3 megapixel sensor. Some of the features that you're used to are available, right? So you have your onboard storage, you have some indicator lights, you have a rugged IP67 housing, So this camera is really intended for that industrial application with the, all aluminum cast housing, shockproof, all that good stuff, waterproof as well, or spray proof rather. The wraparound indicator, and then the connections you already know if you know the Insight product line. So you have an Ethernet, an industrial Ethernet connection. So on this line, we support factory floor protocols like Ethernet IP, Profinet, kind of right out of the box for your communication integration. We have a separate cable for power and I/O, so for 24-volt power and discrete I/O to the camera. We have an external lighting connector, so if you wanted to do external lighting, that's an option. Basically, hook up an external light right to the camera. We support all of the integrated lighting options, illumination options. So lots of modularity here when it comes to the lighting and the lensing. So C-mount lenses, autofocus lenses, different color ring lights integrated right into the camera here, polarizers, diffusers, all that kind of stuff. And then what's unique about this camera is its ability to run, sorry, these are going without me pressing anything, to run our Vidi tools. And so there's some specialized hardware in here that allows the camera to run these deep learning tools in production at production speeds. One feature that I forgot to mention, sorry, I don't know why this is just going all by itself. I don't know whether that's me or whether that's the meeting. But HDR Plus is another great functionality that we've introduced recently in our cameras. So this is to help with illumination to get the most contrast in your image possible. If you've seen a demonstration of this, you know kind of how powerful this technology is. So that's all wrapped in the familiar Insight package. So again, this is what we call a smart camera. So it has everything you need for deployment kind of right in that hardware. There's no need for external controllers, no need for external anything really. You have all your factory communication protocols built in. This camera is self-contained basically. Once it's ready to go, once you've set it up and trained it, you just put it on the plant floor and it just runs. So in terms of the tools, obviously the unique component to this camera is the Vidi tools. So those are the deep learning tools. We acquired a company called Vidi about 3 or 4 years ago, and we've been able to take their technology and basically use it on the Insight platform. So if you're familiar with the Vidi product, a lot of what you're used to seeing in terms of setting up and training Vidi tools and deploying them and the performance you can expect from those tools, all of that is basically integrated into the Insight environment now. But in addition to that, you have your traditional vision tools. So many vision applications call for a mix of deep learning tools and traditional tools, these more challenging applications, that is, where deep learning is required. There's still definitely a family of applications out there that don't require deep learning, but for those more challenging applications, and we'll get into some examples as we go along, where deep learning could be advantageous, right? This is the kind of the path you would pick, the Insight D900. Where you still have access to all of the Insight tools you know, right? So PatMax Redline, doing blobs and edges, histogram, ID tools, all that stuff is available for you. So you can mix and match these tools based on the application. And this is all possible, again, because there's some specialized hardware on this camera. So in addition to 4 ARM cores, we have 2 what we call inference engines. And so those are, again, just basically specialized hardware that allow us to run this really computationally intense deep learning, these neural networks on an embedded system on the plant floor. So just a quick intro into deep learning and how it's rooted in human learning, so how you and I learn. So in this analogy, we're gonna talk about how a toddler might come to learn what a house means or what a house looks like. And so if you were to try to teach this toddler what a house means, or what a house is rather, you wouldn't give them strict rules, right? You wouldn't say, a house must have a front door and must have 4 windows and it must be this shape and it must be this color, because you can't define a set of rules to match all the different variations of what a house can look like, right? So instead of doing this rules approach, you would be showing them a ton of examples, right? And by seeing these examples, the toddler can basically build their own little model of what a house could mean. And so we call this example-based learning, and this is exactly how deep learning works. So taking that analogy to a vision application, in this example, what we're looking at is something like an air filter, right? So you can see in these three images, these are all, excuse me, images of what a good part can look like. So right off the bat, you have a really kind of challenging textured surface, right? This wire mesh, and in this application, we're spinning that air filter, and so as the filter spins, this seam comes in the field of view. And so, again, you can see every time you acquire a new image, all the fins of the filter are in a different place. There's different textures, different shapes. Trying to tackle this with a rules-based algorithm to even just to account for the variation in what a good filter looks like would be challenging. Then you throw into the mix, so again, just covering all these different variations in what good looks like. Then you throw into the mix what a defect can look like. And us as humans, we can, because we've seen these three images of what good looks like, we can pretty easily pick out these areas where things don't look quite right. But again, trying to tackle this with a rules-based approach with something like edges and blobs, and maybe some patterns or something in there to try to account for all the variation in what good can mean, and then also reliably be able to pick out defects would be challenging, right? And that's where this example-based learning really comes into play, and having an algorithm that can, on its own, establish this definition of what good means and detect anything that falls outside of that definition of good. That's where that example-based approach comes into play, and that's where our deep learning technology really shines. So in terms of the workflow here, for all these different tools, the workflow is pretty much the same, and it's very simple. So you collect and label images. So in this phase, you're taking all those images of your part, you're trying to show or collect a representative database of what your filter can look like, what good means, and you're labeling that as good. You're training your tool, and you're validating the results. So this training phase happens on a GPU laptop or a GPU computer, and then you basically push this trained network out to the camera, and we'll get into this in a little bit, talk more about the mechanics of where things happen. But part of that phase is also the validation, right? And I'll get into this a little bit too. Vidi does a really good job of kind of setting that up for you. So to give you a really good idea of how this algorithm is going to perform on the plant floor, right? So because you're not setting up these rules and these algorithms and stringing functions together in your spreadsheet, the only way to validate is basically to test on images that weren't used for training, and Vidi kind of handles that for you internally and gives you a feel for what the performance can look like when you go to deploy. In terms of the software, so we're calling this new iteration of Insight, we're calling it Insight Vision Suite. And this is where we have our Insight Vidi systems and our D900s. And you can see that this is, if you're familiar with something like the Profiler product that we had, this is a similar looking feel. So out here at this level, you kind of have your device pane, you have your utilities to configure individual devices on your network. And from there, you connect and you're in the spreadsheet environment. So again, this is a familiar environment for many of our customers. If you're not a Cognex customer, you don't know or you aren't familiar with spreadsheet, this is basically how we set up our vision tools. And it's much like programming in Excel. So if you've ever used an if statement or anything in Excel, very similar, very powerful, very easy to use. And you have your toolbox of tools, right? So here you have all the different tool types you can use in a vision application. And the newcomer here are obviously the Vidi tools. And so we'll talk about each of these tools in a little bit more detail further on. My point here is just to show you kind of how you can leverage the power of our spreadsheet with the power of all of our tools and combine them in all sorts of different ways to get this camera to do what you want it to do. Just walking through a bit of what the application flow might look like. So step one would be to acquire images. So in this case, part of the user interface has this nice film strip where you can basically use a record functionality to, to have your part under the camera, spin your good parts, collect a good image database of what your good part looks like, record that right into the film strip, and then you have to add those images to your Vidi tool, right? So just like I mentioned before, the Vidi tools are just a tool in your toolbox, and you drag that tool into an empty cell like you would any other tool. And from there, you open its property sheet. So this is a concept for all of our Insight tools, this property sheet, and you set the inspection region for the area that you want to inspect. And from there, you open up the Vidi tool. And this is, if you're familiar with the Vidi Suite product, to date, it's been a PC-based product. But again, now it's in our embedded smart cameras. But this is the standard Vidi user interface. So if you've used the Vidi Suite before, this will look very familiar to you. And all you have to do is drag those images right from your film strip into Vidi, and those become your images that are used for training or testing. There's some parameters here on the left. I won't get into this too far. I'll just talk about a few of them just to kind of give you a sense for what it looks like to set up a deep learning tool and kind of what's available to you. The most important one here is the feature size. And you can set the feature size in pixels. You can also use this bubble down here and kind of use that, scale that to your image. And basically, this is kind of helping you steer the deep learning tool to the kind of the level at which you want to detect defects. So if you had really small defects, you would set that feature size to be pretty small. If you had bigger defects, you would set it to be a little bit bigger, and the tool would run faster in runtime. This is it's like a scan kernel. That's what you're defining with the feature size. And there's some other more advanced sampling and training parameters that you can use to kind of steer how Vidi learns about your application, how Vidi learns and trains from your images. One thing that's really nice is this concept of perturbations. And so what you can do here is, we call them perturbations, but you can think about them as augmentations. And with these parameters, you can basically tell Vidi to take your images that were used for training and add a little bit of variation, add a little augmentation. So in this case, we're adding a little bit of luminance and contrast. And so what that means effectively is that in the training process, Vidi will take your images and add a little bit of lighting, add a little bit of luminance, plus or minus 5% or 3%, or plus or minus 5%, 3% of contrast. So it'll change the images a little bit and add that into the training set of images. And so in that way, Vidi can account for something like lighting variation in your application without actually having those images included in the training set. So again, just a nice little tool to help you make a more robust neural network after your training. And so once that's all set, basically for this application, we only changed 3 things. Basically, we dragged and dropped all these images into Vidi. We're going to set our feature size and add a little bit of luminance and contrast. And again, we'll go through a demo here, so the mechanics of setting this up will be a little bit more familiar. And once that's done, we're going to hit the train button. And that's when the neural network will basically go through its training process. It'll leverage the GPU you have on your computer or your laptop, and within a matter of minutes, you'll have a training tool. So a little bit more about that training process. You're going to label your views, right? So this is basically you as the user showing the network, showing the Vidi tools what's good and bad, or where the characters are and what they are. This is like you creating, I like to think about it as creating an answer key, right, for the neural network. And so when you create this answer key, and the answers look different depending on your tool and your application, right? In this case, we're just calling each of these images either good or bad. That's kind of our defect detection tool. That's how that's set up. But a portion of those images will be used for training, and the other portion will be used for testing, right? So this testing set of images is not used for training, but because we know what the answers should be, we can use those answers and compare to Vidi's prediction to get a sense for how that tool is going to perform. So my point here, the key takeaway is that there's a really nice built-in mechanism for validating the results of your tool, of your neural network, against images that were not used for training. And then that data, those statistics are visualized, right? So in this process of validation, you have this database overview here, and you can see kind of how the network performed. Just at a high level here, this is what we call a score histogram. So for each of these images, Vidi's going to give a score, and that score basically correlates to how confident it is that there's a defect in the field of view. So you can see for some of these images here, it's finding defects, it's giving it a higher score. And so this histogram just gives you a feel for all of your images that were labeled good are in green, and all of the images that were labeled bad are in red. And so it kind of gives you a distribution for how those predictions ended up scoring, right? So long as you have separation between the two groups, then you know that Vidi can detect the difference between a good and a bad image. And then this vertical line here where the arrow is pointing, that's your threshold. So now you as the developer can set basically whether you want to set your threshold right in the middle there, or whether you want to favor, maybe you want to favor false positives, or you want to favor false negatives. That's where you can set basically where you want the system, how you want the system to behave, and what you want it to reject or accept. So here's just a quick, zoomed in example. So you can see after the tool is trained, it's going to start coloring in these regions where it's picking up defects. And so here accurately, it's picking up a pretty challenging imperfection in this air filters mesh. So that's a little intro into the Vidi tools side of things. Another thing that we're really excited about with this new product is the Web HMI. And so this is the ability for you to design an interface for operators or production managers on the plant floor. So on the left here, this is our development environment for the Web HMI. So you have a ton of, another whole toolbox of tools that you can use. You can add all sorts of controls, all sorts of outputs right to that Web HMI, and this is what the final product looks like. And so when you're in production, this camera will excuse me. So when you go to production, you basically connect to the camera via a web browser, and this is what the operator can interact with, right? So you have all the controls you set in the development environment, right? You can set the threshold if you so choose. You can see the results of inspections. You can put the camera in a pause state, all this stuff. Again, really configurable, very customizable, something that we haven't, something that's an improvement over our current custom view and vision view interface. And again, this is all basically free because all you need to display this on the plant floor is something with a web browser. So in terms, just real quickly, of application deployment, what this looks like. So I kind of mentioned this a little bit, this need for a GPU, right? So when you're developing your application, you're collecting your images, you're connected to your camera, you're collecting your images, you're setting up your Vidi tools, you're setting up your spreadsheet, you're setting up your Web HMI, and you're doing that all on a laptop, kind of in an offline state, and you have a GPU on that laptop, and that's what allows you to train these neural networks really quickly, right? That GPU makes training times, something on the order of minutes as opposed to hours. And this is when we have a licensed dongle, which allows you basically to run this new Insight Vidi software. And then when you go to deploy, you basically push that job to the camera. And then when that camera's online on the production floor, you interact with the camera from the WebHMI. So I'll talk briefly about some target applications, talked a little bit about the tools and the hardware. So now let's talk a little bit about applications. There's really three, we call them application tools. And so these are kind of three tools that we have tailored to specific application types in the industries, in the machine vision industry. So we call them Vidi Detect, Vidi Check, and Vidi Read. So Vidi Detect is pretty self-explanatory, right? It's a defect detection tool. Vidi Check is what we call an assembly verification tool. So what that tool is doing is it's looking for features of an assembly to be the right features and in the right place in your image. So we'll get into a bit of an example there. And then Vidi Read is our deep learning OCR, so optical character recognition. We're really excited about this tool. OCR has there's a lot of really challenging OCR applications out there, and deep learning is really well suited to tackle those. If you're familiar with some of these Vidi suite tools, basically these Insight Vidi app tools are just are a subset of our full Vidi tools. There is you can get the D900 in what we call a Vidi complete model, where you have access to the whole tool suite that you're used to in Vidi Suite. And so those tools are called a little bit different. They're called Blue Locate, Red Analyze, Green Classify, and Blue Read. And there's some advanced functionality there and the ability to chain these deep learning tools together, which I can talk to a little bit further on. But again, this is kind of a more advanced mode. If there's anyone out there familiar with Vidi Suite, they'll be happy to hear that all of the tool types are available in this Insight D900 embedded platform now. So in terms of a few applications for Vidi Detect, so a few application types here, in this case, looking at medical screws for imperfections. So you can see here on the screw, this is another one of those examples where the part is going to be spinning in front of the camera. So there's tons of contours, there's tons of edges, this shape is changing constantly. So again, trying to tackle this with conventional vision tools, so with a programmatic approach, would be very challenging to find these imperfections. But with deep learning, again, all we have to do is train a good set of images that represent what that screw can look like as it spins, and the deep learning network can start picking out anything that deviates from that definition of good. Similarly, for some of these more challenging inspection type applications, defect detection applications, basically this this tool is capable of detecting any type of anomalies that might be present, right? So again, we train on a collection of good images that represent kind of the range of what good can mean, and then anything that falls outside of that range is detected as an anomaly. So bent pins, there's a little bit of a burn mark here. In this case, looking for these scratches on a highly textured surface. Textiles, so looking for imperfections in the weave. All those types of applications would be great for Vidi Detect. So coming back to our air filter example, this is kind of what a deployed application might look like on the WebHMI. So again, you have your kind of like your live image, you have some status, you can track the score that gets output from Vidi. You also have access to those defect regions. So if you wanted to do something like classify defects by size, you could certainly do that. Another feature is the online film strip. So you can review any failures that you might see while you're monitoring the camera, or save the failed images, all that kind of stuff. Here's just that same quick example of that defect being identified. Talk briefly about Vidi check. So again, I mentioned this is for assembly verification. The intent of this tool is to check a product that for all of its components, right? So this, in the same way that we learned what good can mean in the Vidi detect tool, in this case, we're learning what these different components can look like by example, right? So in this first automotive fuse box assembly, right? These, you might not have the part in the same exact place, and the lighting might be changing. Perhaps these fuse boxes, these covers are coming from different vendors, and they look a little different depending on what vendor they come from. And again, we'd go in and we train examples of what each of these relays or fuses can look like. And then this assembly verification tool basically just confirms that all of the components are there and that they're all in the right spot. So in this way, it's almost like a deep learning pattern matching tool. And this assembly verification tool, what it does is it checks that all of those patterns are in the right spot. So another great application for this is fit and finish or final trim of automotive components. So making sure that the right component is in the right spot. So looking for differentiating between maybe like a chrome door handle and a plastic door handle, and differentiating between these different types of wood trim. So again, that's kind of like the application family that we're targeting with this assembly verification tool. Similarly for kitted components, right? Again, these kitted medical assemblies can vary quite a bit. They can be difficult to train traditional pattern tools on because the plastic gets in the way or the components change, or there's not really a great feature to key off of for a pattern. But again, with deep learning, right, basically there's a ton more flexibility in what the tool can learn as the variation in what your part can look like. So here's a quick example for the Vidi check tool for assembly verification. So in this particular example, we have, we want to make sure that these capacitors are in the right spot, that they're present and in the right spot. And just like this, similarly, we want to check this connector to make sure that it's connected and in the right spot. And you can see here that this connector, kind of in its good state, exhibits quite a bit of variation, right? There's a little bit of variation in how it's placed, and depending on maybe which supplier it comes from, it might look a little bit different. But again, training all these examples in as examples of this connector, the neural network can handle all that variation. But then when it comes to checking for making sure that that everything is assembled correctly on the plant floor, right? Anytime that there's too much deviation from that definition of what that feature looks like, you'll fail, right? So in this case, we're showing an example of this assembly verification tool failing in the case that the contact, or the capacitor here, the contact is bent, or this connector isn't connected. And so finally, I'll talk briefly about the Vidi read tool. So this is optical character recognition. So this particular tool, kind of spans all different types of industries. Any cases where there are challenging character recognition applications, anytime where Insight OCR Max couldn't keep up, now we have an answer to that, right? And that's deep learning OCR. And so this is great for those types of applications where it's really difficult to pick out those characters because there's a wide range of contrast. There's poor resolution, or poor character quality, or there's just a ton of variation. If you imagine this lock code on like an IV bag that's already been filled, if that's being backlit, you'll see those characters have bubbles behind them, have gradients behind them. Have a little bit of, you can see here, there's a little bit of aspect ratio change. Again, this is really where deep learning shines, and it can tackle these really challenging variations. So just to give a quick example, right, here's an application where we're doing OCR on a date lock code on a bottle. So you can see here that the background changes, right, depending on what juice is in the bottle. You'll get a totally different background. You have potentially even different prints or different plastic shapes on the bottle, and so the date lock code is inkjetted onto that bottle, and so those characters are doing all sorts of things. They're you can see here, like this W is on a contour. Just a quick example of some images with this approach. Again, there's quite a bit of variation here, but especially with this 3 or this 0 there, but you can see that Vidi's got no problem. The Vidi read tool has no problem reading those lines with 100% accuracy. For this example, right, it's the same job, same exact tool, in fact, reading characters that look quite a bit different from the first example. And again, in that case, that might be hard even for me to detect the difference between a 9 and a 3, because if that dot wasn't there, if it was just a little bit closer to the O, it might look like a 3. But again, Vidi can accurately read that as a 9. Same case here. So in this case, you have a little bit of quality difference in the character, right? You can see these dots are quite a bit smaller than the neighboring dots. But again, not a problem for Vidi read. So that was a quick intro into the hardware, into the software, into the tools. We have a ton of content on YouTube. So if you want to learn a little bit more about applications for deep learning and factory automation, if you want to learn a bit more about these tools, you can watch me go through applications. But we'll transition over to Mike, who will do a live demo for you. So he'll go through the same kind of steps and walk you through what it looks like to collect images and actually train a tool live. So with that.
Thanks a lot. Thanks a lot, Bart. I'm going to transition, and I've got while we're making that transition, I wanted to bring up a couple questions that came from the audience. We'll do more Q&A at the end as we get set up for the live demo. But one of the questions was, which I thought was good, came from Bill, and he was curious about cloud-based training and interaction. I know it's an HMI sort of interface, kind of a web-based interface, but is there any plans for a cloud-based training solution?
So it's on our radar. We have a good number of customers asking about that. There's obviously some security concerns when it comes to putting confidential images up on the cloud, but that is something we're actively exploring. It's not something that's available yet.
Okay, sounds good. Mike, are you ready? You're not sharing your screen quite yet. All right.
I am ready. Yeah, let me know if you can see that okay.
Yeah, we're good. I think everybody's ready for the live demo, and we'll do some more Q&A at the end.
Okay, excellent.
Take it away.
Thank you, Silas. Thanks a lot, Bart, for the intro there. So the demonstration I have here is so I have an Insight D900 set up about 15 or so inches away from the part. I'm using a white light, and it's also polarized. And what we're going to take a look at here is some sample cards that have a carbon fiber print on them. And there's a lot of variation in the print as far as the lighting and the texture goes. But what we're going to find out is that we're going to program this to easily see some small features here. So you can see I've got that OK1 sample card there. Do a quick trigger here and show this tiny feature. I'm going to zoom in on that to give you an idea of what we're trying to detect. And I think this really showcases the power of the detect tool, as we're basically looking for that small missing stitch area there. And we're able to detect it even though you can see that lighting and the brightness variability across that surface there, and it still just hones in on that part. So it's a really powerful inspection tool for cosmetic and defect inspection. And let's go over how we would set that up. So program-wise, it's a simple spreadsheet program. I'm doing a pattern detection for a fixture, and then we're just locating the Cognex logo here. So finding that and then fixturing a Vidi detect tool, which is going to look for this region on the different card samples here. Now, as Bart mentioned, the first thing you would need to do is take some pictures of good and bad parts to do our training. Now, I've done that already here down below, and I gave it a couple examples of bad parts, and then about 15 or so examples of good parts here. And I gave it about 3 examples of each good sample, and we have four good samples. Now, taking that, we went right to our detect tool. And after you drag the images into the film strip here, what you then do is label the images and set your defect size. So for defect size, I went down to one of my bad parts, grabbed the little transparent, floating circle here, and just roughly put it around the part there, and adjust it for about a 40 pixel value. And then we label the parts here. So this is where Vidi makes it really easy to sort through your data here. So I have the images below named as good and bad. So I would basically just take here and just do a quick search for good. It would bring up all my good parts. I would go actions for these 15 views, label views, and then select them as good. And I would do the same thing for the 2 bad images there. I'll go back to all. You can also simply just click on an image, and it can change from good to bad as well. So it makes it really easy to label the images here. Once we've done that, we set our training set. And in this particular example, I've selected 50% of my good images I want to use for my training set. And it randomizes it, selects them there, and then we hit the brain to train. Now I won't do that here for time's sake because it takes 3 to 5 minutes or so to crunch that data. But once we're done, we get this nice confusion matrix here, which showcasing all the images we've labeled as good. It's accurately detecting them as good here. And we have this nice big divide between good or bad. So a big threshold that shows the 2 bad parts, and you can easily sort through data here. So if I only want to see my good parts, and click on that, and it'll jump to the good parts here. You can see flipping on these good parts, you can see where it's finding those features there. So let's go to a live setup. So I'll go back to the spreadsheet here. Once you do that programming and such, it locks in all that data into our tools, and we get our display data here showing area perimeter and gives an X and Y coordinate of the feature. I broke out some of the information here just as far as graphics and my threshold so that we can showcase it in the HMI. And I'm going to go live. Excellent. All right, so here's the web HMI. This is in a live mode. It's sitting here taking pictures as it's going. So just going to give you an example of it detecting anomalies that are in this field of view. So, get my finger in the way, it's going to detect that and show that as a fail. This is let me zoom in a bit here so we can take a look at that card a bit more closer. And so this is OK1. I'll just switch through the 4 different OK versions that we have. Showcase how we're, see that variation that's in each card, how it easily shows OK there and OK4. That all looks good. So no defects being shown. You'd see any kind of red highlighted feature on there. So let's flip through and just show the downside here. So you can see here on this live view, it's highlighting and finding that particular feature there. And I'll go through the other samples because they're all in different fields of view. They're all in different shading and different areas of the card there. You can see how easily it is to be able to find that. So if you're a traditional machine vision user and you're thinking of, which tools you might use to do this, it seems like it's almost impossible to try and program to find that there. Maybe with doing some image subtraction, you could do that. But with Vidi, it's nice is you get some variation here as well. So, I can move the card around the field of view. We get some depth of field there. So you can see it at a bit of an angle. And I'll change the lighting here. So I'm physically going to cover the light a bit. And you can see how I'm making it a bit darker and abnormal than what I've trained it on. And yet it still doesn't give me an error part there, which is nice. It helps if you have maybe variable lighting throughout the day in your factory, this will help out with some detections. But now let's give it a couple other examples. So I'm going to take this is an OK card, so there's no defects on here. And I'll actually take and write and make a couple of marks here on the card. And you'll see that it's finding new defects that we're adding into it, that's not in the training set there. So it's able to find and see these different features, anomalies from what we programmed through, and quite robustly there. So let's just give it another example. See how easy it is to pick those up. Let's take a look at just a couple other defect examples. This has got a puncture mark on it there. This has got a couple of pen marks. That's easily seen those as well. And we'll take it offline and go back to the main setup. But that is a very quick and easy programming environment to do a fairly complex inspection there in a pretty short amount of time. So let's just open up here to see if there's any questions at this point as well.
Yeah, very good, Mike. It's pretty amazing stuff. I mean, if you've played with machine vision before trying to do some of these applications, I really look at that OCR code reading as a really difficult one that we found in the past, just the variation in printing and orientation and trying to recognize letters. And, maybe just as a sort of comment from me, I know our team has collected many applications, and I wish we would have collected more, but I think we're what 99% of old applications we just couldn't solve before we're able to solve with the Vidi that were basically not solvable with traditional vision. Is that sort of your experience? Can you maybe talk to that a little bit, Mike?
Yeah, absolutely. Especially on the OCR side of things. There's been some applications just on the defect side of things where I think this opens up a lot of possibilities. Especially on a cosmetic type where the feature or the damage to the part can be anywhere. Traditional machine vision tools, you're programming all these different areas, and you're setting up maybe blob tools or histogram tools, and the lighting has to be key. So you have to account for all the areas where these potential defects could show up. Versus with Vidi, you just give it a bunch of good examples, and it's going to flag any anomalies there, and then you can set your boundaries on what's pass or fail. So it really opens up any of those cosmetic type applications, looking for scratches, dents, dings on products. And then OCR, from the applications that I've tested here, and maybe Bart can say this as well, but I find that if you can look at the label, text, whatever print that you're trying to read, and if you can read it yourself, odds are we can get the Vidi tool to read it as well. So there's the segmentation, the character spacing, the backgrounds, as long as you program and account for that, it makes for a really robust inspection. And if we have time, I can show a bit on the OCR as well.
Okay, sounds good. I have a few more questions.
Yep.
One of them was just generally, can you give us a cost range of the D900? And this is specifically on the D900. Obviously, there's a PC-based Vidi solution, but on the D900, what should customers expect?
Yeah, absolutely. So hardware camera itself is being offered in the 2.3 and the 5 megapixel version. The camera is going to start at 11,500 up to about 15,000 for the camera itself.
Sounds good. I have a question from Stacy here, and maybe this I'm going to word this correctly, but she's asking, can the tools calculate the percentage of surface area that fails or passes?
So
yes.
Yeah, you can't see it here, but on Mike's screen, you can see that there's a cell for area and X and Y. And so for each defect region that's detected, you'll get its location in terms of the center of mass of that region, and the area in pixels. And so if there were multiple defect regions, you would have multiple rows of data, and then you can use that to make judgments, right? Make pass-fail decisions, or tie that to logic for a different tool, for example.
Okay, sounds good. I know in our sort of initial experience, we've certainly seen a lot of OCR bags, whether they're closed or not fully. We've seen a few cracks or sort of blemishes, scratches or cracks in products. So those are certainly items I think to target on this. What about sort of one of the questions came from the crowd about printing, so if you want to make sure that you have the right product in your line, let's say peanut allergy, that sort of thing. Is that something that Vidi would be good at?
Yeah, definitely. Especially, couple that with a traditional match string type verification where you want to make sure that you're printing either, the right label, the right date code, the right product ID on the product. It just gives you such a robust OCR tool that you're able to read all the characters, and then that could be programmatically set up so that you can make sure that you're reading the right character string. So that can be set up from either your system pushes the data that it should be reading, and then Vidi reads and matches to make sure that it's there. And just at a really high rate of success for the OCR reading. So yeah, that's an excellent application for that.
Great. Well, I think that's going to end our webinar. We certainly filled this time up. Please, if you do have applications, send them to Olympus Controls. Feel free to email me. I'll get you to the right resources. And thanks for joining. Please join us for another Webinars from Anywhere. Thanks again.
Appreciate it, Silas. Thank you very much, everybody. Have a good morning.